Ladies and gentlemen, we're starting the session, so grateful if you can please take seats. I promise you that we'll try to ramp up in 30 minutes or so. We're much behind schedule. So grateful if you can please take seats. This is the last session, and I recognize that we're 2 hours late. I'll try to make the session to the point as much as possible. My name is Abdullah Al-Abri. I'll be chairing this session, and it's on a very interesting topic. I'm a consultant at the International Energy Agency, and I have with me seasoned experts on the subject. Today, we'll be talking about the broad definition, perspectives, and prospects of natural hydrogen. So I have with me today Mr. Stefan Ever. He's the Chief Executive Officer of HyNat, which I understand is for Hydrogen Natural. And I've got with me Olivier Loti. He's the Special Advisor Hydrogen for Stonergy. And I have with me Uthman Sarki. He's the Director of Mining Exploration at the Office of Hydrocarbons and Mines here in Morocco. Before I move on, I just want to say that we've been so much talking about the colors of hydrogen, whether it's green or blue. And there's nothing wrong with that. We've seen a lot of discussions, a lot of developments on the green aspects, particularly in the previous 2 sessions on the technology and the scale up. And if I can share with you a story that happened to me 6 to 7 months. I have a 7-year grader, a son, and he was asking me, he's so much into sustainability and he's so much into, this global warming, the new generations. He was asking me about why we don't, what's the solution to this global warming? I was telling him that we need to transition, and we need to look for green ways and more efficient ways to live in our day-to-day lives. He was saying, that's simple. We just need to switch from oil and from gas. So that's the mentality. But then when I went on and I explained to him that, no, this is not that simple. We've been stuck with oil for more than a century. Basically, we've started the oil production in the beginnings of the last century, and we were so much accustomed to the oil and to the gas and the industries and the applications that were so much associated with oil and natural gas. So it's not a switch overnight. And why I'm saying this, because there is an established energy system today that's kind of suffering. And that energy system is so much based on oil, gas, coal, nuclear, and those archetypes that everybody knows. We're so much now talking on the green hydrogen, and nothing wrong about that. It's always good to leapfrog into the future and sweat our assets, sweat our minds into the development of the technologies. But today, in this session, it's a particular interest, natural hydrogen. There is so much of stocks out there that the humans did not pay so much attention to. There's another contender in the game of energy that may as well be so much competitive and can be the bridge, the structured bridge for the whole world to really transition from the fossil-based world and fossil-based economies to a broader green economy and green hydrogen. So this is what the session is all about. I had a nice chat with these seasoned experts, and we were chatting on how can we cascade the message in a very structured, nice, and an interesting way. And I'm pleased to say that the layout is that we'll give a short presentation. So every speaker will give a short presentation for 5 minutes. We will start with Olivier Loti giving us the general definitions of natural hydrogen and what does it mean, what are the prospects, and what's the size of a cake, if you like. What's that? How much reserves does the world have, and where are we at? And then we'll move with Uthman Sarki so that he give us the perspectives from Morocco. How does Morocco see this? What's the national strategy? And if there's any footing already in the ground. And then we'll deep dive into the projects. So are we in the game? Are we behind the game? Where are we at? So this is basically the layout. And after they give their 5 minutes intervention, I want to fire up the audience. So I want to get the questions from you for another 10 or 15 minutes, and then we should be concluding the session. So I really want this section to be interesting. I know it's already in the evening. So without further ado, I want to invite Oliver Lotti to give his first intervention. Thank you.
Can you hear me? Yeah. Okay. So can we start with the slide? Yes, thank you. So good evening, everyone. So I will just introduce the topics as some of you may not be familiar with natural hydrogen. So first, you can see what we call Ferri circle on the slide is a kind of elliptic structure that we can find on the surface where we have measured emission of natural hydrogen with sensor. So you can see that the vegetation is not growing anymore. And so some natural hydrogen is produced from the earth. On the next one, I don't know, it works, yeah. So how it is generated. So as far as we know, it's coming with the water, you know, I don't know if the pointer is working, no. So the water is percolating in the basin, as you can see, and on the point 2, you have a chemical reaction between rocks containing some ferrous mineral and the water. So it's a redox that provide this hydrogen. So it's very similar to green hydrogen. I would say it's a chemical reaction with water giving hydrogen. Another way to generate this hydrogen is radiolysis. So it's the one number that you have here. You can have some radioactive elements in some granite, also in the earth, which also can split the water molecule and provide some hydrogen. So that's by far the two main sources that we explain the generation of this hydrogen. There are other sources, but we will not speak about that. One, it's generated because it's a tiny molecule with a low buoyancy. It tends to, I would say, percolate through the rocks. It could be also reacting with rocks, it's the 6, or consumed by microbes in the 5, and come to the surface, that's the 7, on the Ferri circle that I showed you at the beginning, or through fruits. But what we are looking for, it's an accumulation, so it's the 8. It's, I would say, a trap which can seal by a sort of by a layer salt or by a layer shale, avoid the hydrogen to migrate up to the surface. And through, I would say, a wells, we could produce this hydrogen. And that's exactly what's happened in Mali, in Bouraké-Bougou, where they are producing for several years at small rate, for sure, but I would say a continuous production of 97% of natural hydrogen in terms of purity. On the next, no, sorry, that's the right button. I will describe you the different advantages of this natural hydrogen. First of all, we revisit all the gas analyses that have been made by the past because hydrogen was now, we are really focused on hydrogen for the energy transition. And gas analysis, sometimes we found it, but we forget it because it has no value at the time. But now we are revisiting all this data from oil and gas, from hydro, from water well, from mining, and we see that it happened everywhere, almost in all continents, in different basins. So it's really abundant. And in terms of reserves, we estimated from the quantity that we can estimate that is escaping at the surface, a fraction of it could be accumulated, and to estimate, at least in Storengy, this reserve between 1 and 5 gigatons. The second advantage is the cost. It has a very competitive production cost because it's mainly a well to be drilled and the hydrogen naturally is produced. Generally, the area that you are looking for are onshore at a shallow depth, so the cost of the well is limited. That's why we expect to have, I would say, a levelized cost of hydrogen of production below $1 per kilogram, I would say, in the area that you are looking for. So it's far below the other way of producing hydrogen, including the gray. And the last advantage is the environmental impact. I would say a recent study of the Stanford University, which has computed all the elements for an LCA, so a life cycle analysis of the production of this hydrogen, and they found that it will be less than 1.5 kilogram of CO2 per kilogram of hydrogen produced. So again, it's far away from the other way of producing hydrogen, including the green hydrogen, if we take into account the life cycle analysis for that. But it has also a lot of other, I would say, advantage in terms of environmental impact. It has no stress on the water resources. It has no stress on critical material, scarce metals, and low footprint on surface. So a kind of, I would say, advantage also that make it very interesting. And it's not for, I would say, making comparison with the green. The idea is that they are complementary. It has some advantage, and it will come together with the green hydrogen. Sorry. Just the last slide to show you the momentum that we see the last 2 years in terms of exploration. We see that a lot of small companies, startup, mid or small E&P company are starting to explore for this natural hydrogen, taking some acreage. That's the case where the country have opened their mining, I would say, acreage, like Australia, where we saw a rush last year. France, it's already starting a rush. USA, they already, I would say, the regulation allow already to do this exploration. And we see that a lot of companies now are taking acreage. There's 8 wells that have been drilled during the past year to explore for natural hydrogen, so really dedicated to natural hydrogen. And we heard that some of them are positive. So that's very, I would say, encouraging in terms of potential. So we see that it's the momentum, it's starting, and we will see certainly in the coming months and years, because it will take time also, the contribution of this natural hydrogen. And Morocco is not the least, because the roadmap set up by ONIM allow to also raise this exploration. And I will leave the floor now to Mr. Satki.
Good afternoon, everybody. First, I would like to express my solidarity and all ONIM staff solidarity with the affected families and persons by the tragic earthquake in the house. As Marrakechis and as Morocco. I'm honored to be to take part of this panel. It's important. This is important for us because natural hydrogen is a new substance. It's a clean substance. Is also, I think, zero carbon sources, energy sources. For in particularly the exploration of hydrogen, of natural hydrogen, began in Morocco in 2017 by ONIM. I would like also to introduce our organization, l'Office national des hydrocarbures et des mines, or National Office of Hydrocarbons and Mine, is a state organization, and with legal personality and financial autonomy and governmental control. It is established in 2005 by merged two old organizations, BRPM which created in 1928, and ONAREP, which created in 1981. ONIM is in charge of research and development of mines and hydrocarbons, and also ONIM launched some renewable energy to conform to with strategy, energetic strategy of the country, geothermal in 2012, and natural hydrogen exploration in 2017. ONIM puts the natural hydrogen exploration as a new pillar of Morocco's energy transition strategy, and also to contribute to the national mix energy. In 2017, as I said before, ONIM has carried out preliminary assessment of Moroccan potentialities of natural hydrogen in all Morocco. This preliminary assessment shows us that geologically natural hydrogen can exist, and with high potentiality in several areas. And in between 2018 and 2019, ONIM carried out an expertise, international expertise, with an international expert of this, Zgonik and Larin, and this project is consists on three phases: the pre-screening phase, the screening phase, and the ranking. In this phase, we have several areas ranked. Several areas ranked, and these areas in the southern provinces, we have Rgibachil and southern coastal basins, and in the north, Khmisat basins and the coastal Mesetam. Some criteria is used to rank this area, like density and of geomorphic depression, as Olivier shows before. The geomorphic depression is the first indication of natural hydrogen seepage. As I say, several potential zones are highlighted and ranked, and based on this result, ONIM and HyNat, Mr. Aver will talk about this deeply. ONIM and HyNat with signed or MOU in order to develop the southern province potential. This MOU consists on three phases: field exploration with conducted between 2021 2023, and currently and in progress the geophysical work, passive seismic in the target area. And in the future, we will do the drilling and testing of this system. The main aim of this panel is to give an idea about what natural hydrogen is, because it's new. How are exploring and hoping to produce it, and the benefits of these new resources. Mr. Olivier talked about this in comparing between natural hydrogen and other hydrogen produced, because this is produced by Earth, not by not by industrial fabric. The presence of very active communities like us, and the potential growth in this of this activity, and the need of regulatory, because the regulatory some countries integrate the regulatory, like Australia, like France. In Mali, it's not they take a similitude with the natural gas. In France is with the, I think, with the mines. In Australia with hydrocarbons, and I think that's the three countries what they have regulatory, and we ONIM and the ministry work hand in hand to install the new regulatory in perhaps in mines regulatory, perhaps in hydrocarbons regulatory, but with the benchmarking, it will be better with hydrocarbons. I would like to give the floor to Mr. Aver, which talk deeply about our partnership in the South. Okay. Thank you very much.
Je vais aller très très vite. Approchez-vous. Thank you so much for the organizer, and thank you for the invitation today. I know, first of all, once again, sorry, but we have to never forget that. We would like to offer condolence, affection, and solidarity for the Moroccan people today. Ah oui, peut-être qu'il faut des slides. Non, ça marche. The energy transition to the new hydrogen economy requires ambition, risk-taking, perseverance, and resilience. But requires also imagination and creativity, and rigor, science, technology, and discretion. In short, we are committed with ONIM and us and HyNat. We are committed and confident in making the natural hydrogen project in the south provinces of Morocco a success and an example. C'est celui-là. C'est pas celui-là non plus. Non plus. Ah, yes, it's coming. After 2 years of rigorous work between HyNat and ONIM in the south of Morocco, this year we are finishing the PFS. It's a preliminary feasibility study dans le jargon pétrolier. And now we are about to start drilling the first wells. 3 priority zones has been defined. The final geophysical works are in progress today. Yes. Voilà. Yes, today we can confirm the existence of active and productive hydrogen system in southern Morocco. HyNat will decide to launch the first hydrogen drilling campaign at the end of this year. Je suis revenu en arrière, sorry. And as you can see, natural hydrogen is in the death angle, and natural hydrogen is probably the next energy revolution. Thank you so much. Et vite, hein.
So I once again want to thank the speakers for their interventions. If I can sum up, we've seen how the natural hydrogen has a lot of volumes, still very much untapped. It's 15 times the consumption today, so it's measurable by all means. We've seen what are the cost estimations, and we've seen how much the emissions on a life cycle basis can be only 1/10. Yeah, so that I think ticks many boxes. But for one, the technology is already there, right? We know oil, we know gas, we know drilling. Yeah, so the technology is already there. The economic viability is already shown. The sustainability aspects, I think we can really have a good faith on. And equally important, it's a vector that can address the energy security, which is top agenda today. So very interesting, very aspiring, and I think it's, in many ways, it's called the white hydrogen or the gold hydrogen, right? And we could see why it's called that way. So without further ado, I want to open up the floor for any burning questions, any perspectives to share. Why do you think this has been lagging behind, although billions of dollars were kind of spent on oil and gas exploration? So please share any insights or any questions that you may have. Any questions?
Thank you, Dr. Abdullah, for giving us the floor to also share our insights. But I have a question about the global market, worldwide or the regional market. So is it evaluated? So we know, for example, what is the potential of the natural hydrogen here in Morocco or at the region or even at the international scale? Thank you.
Hard for the questions.
Thank you for this question. First of all, the discovery of hydrogen, natural hydrogen in the Mali is the push of all countries that export for this substance. In Mali, they are drilling water for water, and accidentally they have the emanation of hydrogen. In exploration and in surface, you have a small seepage, not exceeding 1%. For the equipment that not can measure more than 100 ppm. And this is the exploration. After exploration, after surface exploration, after conducting the seismic survey, the third phase is to drill. Why drill? Because the accumulation, because the hydrogen, natural hydrogen is produced by Earth, is produced like a system explained by Mr. Olivier, and we can have an accumulation like gas, like natural gas, but not very, because hydrogen is a small molecule than methane. That's why you can the seepage can continue, and you can't in some time you don't have some caprock and to block the hydrogen, to stop the emanation. But this is necessary and to drill and to have where the accumulation have. For natural hydrogen, it's a continuous system. It's produced continuously, not like methane is produced and stopped. Hydrogen is that's a continuous system and work every time, and it's produced in human life, not geological period. I think it's very or not. If Olivier can add something.
Yeah.
Sorry, Olivier. Another thing with hydrogen is the byproduct. It's not like green hydrogen. In green hydrogen, you produce only hydrogen. In natural hydrogen, we can have another byproduct is helium. Helium is a very critical substance. That's why it's very, very important to have this working system in life. Thank you.
Just to complement on the potential of the different areas. So I gave you a rough number, which is derived from the oil and gas and statistical data that we use to estimate, I would say, rough volume. But I think that now this exploration is still in its infancy. I would say the countries start to look more in detail, and Morocco is typically the case, looking to different areas, different basins. There are many places in Morocco which could be very prospective in terms of exploration. So that's why it will take some time in order to really evaluate area by area, country by country, the real potential that we can obtain.
Thank you. So we have another question from.
Yeah, thank you, of course. Okay, I am Ayoub Al-Qadim Kawi. I am assistant professor in organic chemistry and catalysis from Qadi Aid University. So, as was explained, the hydrogen gas is formed underground and from redox reaction or catalytic reaction or radiation. But my question is about how this technology or to produce or to capture natural hydrogen, how it's captured. It is like CO2 gas or the capturation of gas that we know, or there is a special technique, or it's captured underground. Thank you.
Two words. It's captured like natural gas. It's very simple. No, in underground.
In underground, it's in the rocks, which has porous network, like for the natural gas. It's also some voids between, and the gas is trapped there. You have to have, I would say, a sealing layers above, which avoid that the hydrogen escape. So it's a kind of anticline or antiform that can trap within this salt layer, for instance, the gas in a porous network of a rock. That's basically how it is. And it's the same as for natural gas. That's how the accumulation are found and are produced later on just by drilling in this location. And then the gas is eruptive naturally.
We have another question from the audience.
Maybe just an example, sorry, just an example to precise. When we drill between 100 meters to, depends, but for in Morocco it will be 100 and 1,000. And you can find different level of drilling in the same place. And because you have many accumulation in the ground, and when the accumulation is full, the hydrogen go up and go up and go up. And like this, we can define a strategy, a drilling strategy exactly adapted for, in Mali, it's not the same condition. In, I don't know, in Gabon, it's not the same condition. In South Africa, it's not the same. But depends the location, the place. In Australia, it's definitely not the same. But in Morocco, it's also specific, and we need to adapt the technology and the approach, the technical approach, fonction de la géologie, depends the geology.
In United States, the boreholes, you have 4,000 meters in Nebraska.
We have also a question from the gentleman in the back.
Hi, I'm Stefan from Argus Media. My question is, so we have these few countries that you also pointed out, notably, obviously Morocco, but Australia, the US, France, and so on. How likely, if it's possible to say, how likely is it that we'll find, or that there'll be other very big discoveries in other countries? So in other words, are these countries kind of on the map because this is where we expect the big deposits to be, or are they on the map because these are the only countries that have really, or where people have gone out and really looked for it? Does that make sense?
Yeah, good question. May I start, perhaps, and perhaps it's also more about that. There are many, I would say, locations where we think it's very favorable. Every continent, perhaps every country has a potential for natural hydrogen. There are some geological, I would say, ingredients that are necessary, but we found it, I would say, we found them in a lot of locations. What's really triggered this exploration is the, and Mr. Satki mentioned it, is the regulation. When you have a regulation in place, I would say investments start for this exploration. The investor, I would say, perhaps more securely invest because they perhaps will have some right on the discovery. So that's the first thing. And another thing that can help, and we can see that on the US with the inflation, IRA, and a recent ARP grant of $20 million just for natural hydrogen project. So those incentives in terms of tax or grants are really also pushing this exploration. So you need regulation, incentive, and then let's the company do the job, and they will find something for sure.
And also the taxonomy level, because you have hydrogen, where you integrate this hydrogen, this natural hydrogen, because natural hydrogen, we are in the upstream exploration. For green hydrogen or other color of hydrogen, you are in mid and downstream. See? That's why the regulation is very, very important in order to secure the investment.
Thank you. So this is really interesting. And when we had the first discussion between ourselves on the topic of the session, personally, I come from the oil and gas sector, so I was really cooked in the projects. I was leading a lot of oil and gas projects, and I've run a lot of economics for those projects. So when we had that discussion on the natural hydrogen, I spent the whole weekend reading about why and what's the status of this natural hydrogen developments worldwide. And if anything, the numbers that were shown by Oliver and discussed by the seasoned experts, it just halves the ROI for any projects, compared at least to natural gas projects. So it makes the whole development a lot more competitive economically. And hydrogen is not new as a, production-wise is not new. So all the facilities and everything else is pretty much well known. I like the question on the challenges and the things that were stated on the incentives, regulations, taxonomies, and so on. You know, I'm here, you know, and you know, just, you know, thinking about this is so much lucrative. I think so much promising from an economic perspective, so much promising from environmental perspective, and the oil and gas industry, plus maybe other industries, maybe the mining, have spent billions of dollars on the exploration. So the question is why the world has woken up saying that, oh, we have a son left behind. So why are we late on this? If you can share any perspectives on that. And maybe how do you see the very short years ahead on natural hydrogen development? So if we gather again next year in a P2X summit or